right, welcome back, ladies and gentlemen. We're about to finish these puppies and be done with your trust calculations. So we finished last time, completely finished this guy. We're about to finish this one and this one. So let's get started, shall we? This time things are going to get a little bit trickier because so far we've been dealing with things that have three forces or they're either only X and Y. So we dealt with this thing right here that had three total forces. Three total forces make a triangle, right? So we can use trig or whatever else. Here we have, actually we didn't do this last time, but we're about to because it's a no-brainer for this guy. And on our last one, whoops, which I moved over here, we had, straight X and Y, and we had straight X and Y. So we had pretty basic stuff. But now we're going to get into things that have four forces or more, which creates a problem. Okay, so let's get into that. So first of all, we were in here and we did joint A and found out that AC was in tension or in compression and AB was in tension, and we found the forces for those members. Now we need to find out the rest of them. So I should have done this in the last video, but I didn't, to go to joint B, because joint B is pretty basic. You have a downward force. Here's B. Mine happens to be 220. We have member AB over here, and we have member BC over here. We found out earlier that AB was we found out earlier that AB was 158.36 in tension, and because it's in tension, it is pulling, right? Okay, and we found out that it was 158.36. All right, so let's make this a no-brainer, okay? So that means that BC is 220 going, and it's because this 220 is pulling, that 220 is pulling, okay? And oops, sorry, I forgot to put that this is BD over here. And BD is going to be, because AB is pulling, BD will be pulling. So that will be 158.36 going that way. Okay. So BC is pulling, it is in tension, and BD is pulling, so it is in tension. All right. So we're going to update our summary box. BC was 220 in tension, and correct, and BD was 158.36 in tension. And notice that things kind of keep repeating sometimes because we have opposite and equal, right? So that brings us to the next issues, which are going to be a little bit more difficult. All right. So now, actually, before we do that, I'd like to go to the last one and get to the point where actually we did that, where we only have one left. Okay, so here's the deal, folks. You've solved this one. If you've solved that one, and you have only one left on this one, and you have only one left on this one, I'm going to give you a B. Okay, you're going to get 80-something% for getting all of that done. But if you want an A, you're going to have to go to the next step, which is a little bit more complicated. So here we go. Let's talk about this. So all we have left is CD, right? Now, where are we going to look at that? We could look down here. There's 4 forces, but only one angled member here. Up here, there are 1, 2, 3, 4 forces, but 2 that are angled. That makes this a lot more complicated. We could do it, but it's more steps. So let's go down here and do D, because it's a little bit more basic. Before we do that, let's update what our forces are and what direction they're going over here. RFDX was going this way at a certain force. Your arrows will all be the same way as this, but they'll just have different forces. RFDY was going a certain amount that way. Okay. Actually, I take that back. Depending on what this force is, you might have differences. These two might end up being a little bit different, but I believe that you will have these being the same direction. All right, so we know which forces and which directions there are. So now we can get to joint D. Remember, we're only going to draw what touches the joint. So we have this and that, and we have a 56.31 degree angle. This is CD, and this is BD. And we have a force going this way of 125. And we have a force going this way of 175. All right. So now here's what's kind of important. First of all, we have BD, right? Well, we found out that BD was 158.36, and that it is in tension, which means that it is pulling on the joint. So those are the things we know. Now, here's what makes this one different. In all of our other joints with an angled member, we only had 3 total forces and we could make a triangle. This one, you can't do that because all of this affects this. So we can't just simply say, oh, let's move that 125 over here. It doesn't work that way. We have to account for everything. So let's start with our forces in the X direction and our forces in the Y direction so we can determine whether this thing is in compression or in tension. So now in the X direction, we've actually got 3 forces. We've got CD in the X direction, the component force of this. We've got a 158.36 going that way. And we've got a 175. No, 75. Whoops, I don't know why I put 175. Let's go back and change that. Whoops, I don't know why I did that. It's just 75. I'm glad I looked at that. Kind of double checked as we went along. It's 75. So, again, your numbers are different anyway, so you do you. Now, we can't figure out what CDX is because I have opposing things already. But my forces in the Y direction, I have a 125 going that way, and we have the CD component of Y. And now we can figure it out because we only have 2 Y forces. So that means that CDY is going downward, and if it's going down, it's also going right. Kind of makes sense if you think about it because your 2 smaller numbers have to add up to the bigger number and be opposing to that. All right, so we've got now, sorry, I'm a little messy. I'm making this video in the morning and I haven't had enough coffee yet. So here we go. All right, I'll get a little less sloppy. So here we go now. We need to figure out still what our CD is. Now, in order to do this, we're going to need to make our triangle, but our triangle is going to consist of CD, CDX, and CDY. All right, so here's how we're going to do that. We need to know, this is a step that we haven't done yet. we need to know the sum of all forces in the x direction equals 0, and the sum of all forces in the y direction equals 0. Let's see if I can get rid of this shadow. I don't like that. Sorry, folks, gonna have to just deal with the shadow here. Maybe I can make it better. All right, that's a little bit better. So here we go. What do we got in the x direction? We've got CDX plus 75, because 75 is positive, minus, okay, because we've got this negative 158.36 equals 0. Kind of encroaching on the other side there. So that means that CDX is a positive 158 minus 75. All right, so CDX is 83.36. We don't care about positive and negative here because we already found out that CD is pushing, which means it is in compression, right? We already know that. So now we know the X component. Now we need to know the Y component. So here's where CDY plus the 125, because it's positive, right? So we're adding 125 equals 0. CDY equals, it's negative 125. But again, we don't care because we found out that it's in compression, right? Now that we have those components, now we can do Pythagorean theorem. And now we have our components for CDX, CDY, CD. Here's CD. Here is our CDX component was 83.36. And our CDY component was 125. You could put negative 125, but when you solve the problem, it's going to be, all right, so square root of 83.36 squared plus 125 squared. That's Pythagorean theorem, a squared plus b squared equals c squared. And we are going to end up with, I already solved this guy. No, I guess I didn't. All right. We're going to end up with the square root of 83.36 plus, whoops, I meant to do squared, plus 125. Again, your numbers are different, but the concept's the same. All right, so I get 150.25. CD is 150.25. And remember, we found out that it is in compression. Congratulations. You have now solved the most complicated truss. So CD 150.25 in compression. Now, side note, you might be a few decimal points off because it depends on rounding. Like if you looked at your solution that you made online in that Truss solution calculator thing, you might be a little bit off, but you shouldn't be more than one full digit off of those things, but you'll be close. So it's okay if you're, a few decimal places off as long as we are close. All right, cool. Now that we've done that, let's go ahead and look at our last one. Now, what I'm hoping that you'll do, you can watch this video, but I'm hoping when you get to this point that you're going, okay, I need to do either D or I can do A. D has three forces, but we need to figure out the component of it. I think we'll deal with A. It's basically the same problem as what we just did, right? So we'll go to joint A. Joint A has this going on, this going on, that going on, an angle of whatever it is for you. And it's got a force of something going that direction. We've got a B, we've got a D, and we've got a C. Okay. Now we figured out that AC was 0. Okay, already from a different problem way back in step A. We figured out that this has no opposing force and it's 0. Okay, we do not know. We do know AB was 150 in tension, which means that it is pulling. Okay, and that is what we know. Now, again, you can't use Pythagorean because we've got other things going on. Now, in mine, I have a 350. You've got a different value. What I would like you to do is pause this video, see if you can do it on your own based on the same thing we just did. And if not, come back and we can solve this together. All right, here we go. First of all, we need forces in the x direction. Let's give myself some room here. I'm going to do that down at the bottom. So we got forces in the x direction and forces in the y direction. For x, I've got a 350 going that way. I've got my AC, which is 0. It doesn't count. We're not even looking at it. And I've got my ADX. Okay. In my Y direction, I've got a 150 going this direction. And I've got my ADY. Now, anywhere here you can figure out which way, because since this is 0, we know that it's going, ADX is going left. And we know then that it's pushing, which means that it's also going down. So you could have started in either place to figure out this little puzzle right here, right? So AD is pushing, so we know that AD is going to be in compression. Since it's pushing on the joint, it's in compression. And now we can solve for by using the sum of all forces in the x direction equals 0. Sum of all forces in the y direction equals 0 to get our component forces for ADX and ADY, right? All right, here's our sum of forces in the x direction. I got that 350 going right, so it's positive. We've got nothing with AC. We can put it in there, but it's still 0. So 350 plus ADX equals 0. ADX equals negative 350. It doesn't matter that it's negative because we already determined that it's in compression. Okay, our sum of all forces in the y direction equals 0. We got 150 in ADY, so we'll do it the long way. We got a positive 150 plus ADY equals 0. ADY is going to equal, again, negative 150. We don't care that it's negative because when you do Pythagorean, it won't matter. Now we know our component forces of AD. So here's AD, and here's, maybe I should have drawn those dashed before. So here's my ADY is 150, and my ADX is 350. So now we can find out what AD is. Okay, apply Pythagorean theorem. 150 squared plus 350 squared. Okay, so equals AD equals, drum roll, the square root. Oops, let's clear this. Square root of 150 squared plus 350 squared. And we came up with 380.79. We already found out it's in compression. 380.79 in compression. You have solved all of your trusses all the way through. Congratulations. Feels good. And if you're ever asked to do another one again, now you know how. All right, folks. Enjoy. Have a good day. See you next time.